Hello everyone, hopefully everyone can hear me okay and we're all coming through nice and clear. If everything is going okay, hopefully everything's working. Let me have a look. Yeah, there we go, it's all working, brilliant. Hello everyone, welcome to tonight's live stream. This is live, so thank you everyone for joining us, watching us this live. Today's date is the 12th of September, and I appreciate you, some of you are staying up quite late, like Jet, who's at now midnight. Karen, 3:35 a.m. Wow. Okay. So yes, I do have chat open on the side here, and so you can ask questions as we go along, or whatever you want to do. Really, talk whatever you want about. But tonight we are doing what I was meant to do last week, which was to show you how we're going to try to recreate the physics-based obstacle courses that you find in the game's Fall Guys, which we played a couple of weeks ago. So we're going to try and tackle some of the things we saw in that game and try and replicate a few things. So things you're going to learn about tonight's stream, you're going to learn about the physics constraint, you're going to learn about platforming elements, some ragdoll stuff. Yeah, we'll see how far we get, but we're going to hopefully get started with this. We do have chat on the side. So hello everyone, hello Karen, hello Angus, Koenig, gamer creator, underfunded, hello, Arab gamer, hello. Yes, if you want to, I have seen your message on Messenger. I just haven't had no time to look at it yet. My day is quite busy, so trying to get back to messages is quite difficult. But I promise I will get back to it. I will do it probably after the stream tonight. We'll see how far we go and hopefully how long we go. As someone asked earlier, and I missed out who the name, sorry, is. Sorry, but I don't know how long tonight will go. We try to do at least an hour, but it may be an hour, 2 hours. Okay, so we'll see how far we take it. But I say we haven't got much time, so we'll do as much as we can. Before we get started, some housekeeping stuff that you'll know to talk about. Sorry, not you know, that I want to talk about. Patreon. If you want to support me, head over to patreon.com/Ryan Daly. Patrons over there get access to videos way early before anyone else. So they've got the entire crafting series. They've got half of their skill system series. Over half of that's coming out soon for them. They've got the FPS RPG series, which hasn't even started on YouTube yet. So if you want to learn how to make an FPS RPG, they've got a series started up over on Patreon. They've got, what else they got? They've got loads. Loads of odd one-offs. They've got the start of Niagara series. I started doing a Niagara particle system series on there. And there's new voting as well. You've got things about level of details, loads of stuff. So if you want to see that stuff before anyone else on YouTube, and we're talking about months ahead, head over to patreon.com/Ryan Lee. It's thanks to donations from you guys that makes all of this possible. I say this isn't my full-time job. I do have a full-time job as a teacher, teaching games development, and it's your donations that help me do this and afford all this setup and keep doing it. I do enjoy doing it, and I want to keep on doing it. So thank you so much for your support. So let's just get started, shall we? Hello BioBlaze, hello Kim, hello Oliver. Are we going to have a VR series? Yes, you are in time. I was experimenting with it early this year, and you will be getting a VR series later on. Okay, so I've started out with the third-person template here because it's got a third-person character, which is what Fall Guys is. But let's experiment, and we use this room here as a sort of testing bed for our various traps. So the spinning hammer wheels, the seesaws. We can use this space here to experiment with that, and then at the end we're going to try and build a course up with those things. The only thing that won't be in here will not be the multiplayer. Just because we don't have time to do multiplayer stuff. So, let's get started, shall we? So, I'm going to start off with the spinning hammers. So, I'm going to create let's create a new folder, actually, in my content browser. Keep myself nice and organised. So, we'll call it traps. They're not exactly traps, but you get the gist. Gizmos, we can call them. New blueprint class. Actor. And we'll call this one hammer. And this is going to be the spinning hammers that you get. That could either go that way or that way. So I don't have a model. we're going to do it just out of primitive stuff for get started off. But ideally, you would have a model for this. So I need a static mesh. And we're going to use the cylinder. And what we're going to do is just rotate this facing the x-axis and pulling it out like so. X is forwards, so if you've got it facing the x-axis, you know which way is forwards because it always starts off facing the right way. I'm going to do that. I'm going to make this a bit thinner. This is going to be the pole that sticks out like so. And then we're going to make another static mesh. And this will be the hammer itself. And this guy is going to be moved to the end here. Cylinder. Okay. And we're going to just scale that up a little bit. Cool. Okay, so this would be the vertical spinning one. So to do the spinning part, we're just going to use a rotating movement component. And we can use this because it's going to be a physics-based thing. We want to use this instead of something like the world position offset. So do this, and simulation by default does that spinning, which is not the right direction, so let's change that. So with your rotating movement, you can go over to the right-hand side details panel. You'll see rotation rate, X, Y, and Z. Z by default is set to 180, so spinning the Z is like putting a pin on top of it and let it spin around. So rather than do it in there, we want to spin it in the Y on the side. So if let's change Y to 180 and Z to 0, hit the simulation button, and there we go. Now what if we want to tie this to a certain speed? Okay, well let's do that. Let's put a variable in here, and we'll put in speed, and make this a float. Now, the reason why I'm doing this is because I want, as an editor, as a gameplay level editor, I want to be able to quickly, easily tweak and change the speed of my hammers to whatever I want. So I'm going to take this as instance editable, go to my construction script, and here I want to get the rotating movement, get the set the rotation rate, and if we take the 180 as a default speed, okay, so we'll do make rotator and set Y here to 180, which is a default one we want. But then I want to multiply that 180 here by this speed. So if I drag out multiply float by float, oh, type in 180 in the top there, and then drag speed onto the bottom one, and then drag that to there, we've now got speed influencing our rotation rate. So to simulate that and show you that in action, hello, I'll put my hammer into the world. Okay, and if I was to simulate this, or maybe just play it. Stop. Select people. Why is it not moving? Rotation rate. You should be moving. Oh wait, because speed set to 0. That's why. Cool. So click that there. Speed here we'll do it set to 1. Now push play. There we go. Whoa. And there he goes. Okay. So you can see it's knocking me a little bit, but not what I want. So we'll tweak the physics to work with that. Hello. But what I mean by changing the speed here, I can make that faster or slower by dragging this out. So I'm just going to change my speed here to default of 1. And oh, and slider range, we'll make it go from 0.1 to whatever, really. I'll leave it at 0.1. There we go. 0.1 in the value range. So now I can't go that any lower than 0.1. So it's minimum 0.1. But I can go as high as you like. So at 0.1, it goes this slow. Okay. Now, what if we wanted to spin the other way? So rather than making duplicate actors, we could again use the same concept we've got here. So if I make another variable, such as like a Boolean, which makes it anti-clockwise or clockwise, we can tweak that here. So let's take that as a variable and go is clockwise. And at the start of the construction script here, we're going to do a Boolean here. And from that, I'm going to get a select. And I want to select float. Now, this node, what this does is it will take this Boolean in, and if it is true, it will do the top value here. If it's false, it will do the bottom value here. So, I'm going to take this, and if it's true, do 180. Or let's do 1. And if it's false, or B, we'll do -1. And I'm going to multiply that by a float. 180. And then plug that into there. And what that means is now, if I toggle that with the make it editable, the eyeball, I can now tick and make it change direction. But if I change the speed, so let's untick that, and it should go the other way, like that. Yeah. So now we can toggle things. It makes it a lot easier for us to build worlds. So what is good about that? Well, that means that if I want to make more of these, I can change them on an instance level to different speeds, different directions. And you get this sort of nonsense. Yeah? Very quick and very easy, all from one actor. So that's a really easy way of setting up and creating your levels. And again, as a level designer, I could be testing this out and go, that one's a bit too fast. I can just go in there and just turn it down a little bit, without having to go in and change code to fit my needs. Okay. So let's see if we've got any questions whilst I've done all that. Hey Patrick. Hey Timur. How to make an NPC stand still during the attack and not run around me? I can't remember off the top of my head now. You have to like just turn off. It sounds stupid, but you have to just turn off the running part. So you have a different branch for that. Alright, anyway, moving on. So we've got hammers. Hammers kind of done. What I want to try and do though is make it go ragdoll when it gets hit. So how to make it go ragdoll and then make it stop being ragdoll, make you get back up again. The getting back up part will be a bit trickier, but we'll see how we get on with that. Okay, so I'm going to go onto my third person character. And we're going to create a function in here called go ragdoll. New function. Go ragdoll. So to make a character go ragdoll, you have to take their mesh. And with that mesh, you have to set physics simulate. Ooh. Set simulate physics to be true. And then we have to change its collision. So if you click on the mesh here and scroll down to the collision settings for it, you'll see there's collision presets for ragdoll, and they change how they are how the collision is enabled and what the object type is. So let's do that for here. So I'm going to set object type, and it's going to become a physics body. And we are then also going to change what was the other thing we have to change? There was something else. What was it? Oh yeah, collision enabled. So animated set to default is query only, which means it only detects when it's been overlapped and things like that. So instead, I want to change that to be just collision enabled. And I change the drop down here to collision enabled. So again, what would be nice and handy as well to be able to toggle this. So if I go to my Go Ragdoll inputs here and click new input and say is ragdoll, if that is true, I'm going to put this into a branch. So the true branch is going to set off the ragdoll code. The other code, then the false, is going to turn it back off, so make it stand back up. Which again is going to look kind of janky and weird because I don't have a standing up animation. But we'll see how we get on with that. But anyway, we've got go ragdoll. So next thing we're going to do is when he gets hit by this thing, we want to change the ragdoll of the character here. So I'm going to go into my hammer code, into the event graph, and on the hammer mesh here, I'm going to right click, go add event, and add on component hit. If the other actor, we're going to cast to the third person character, because that's what we're hitting. And as third person character, we're going to go ragdoll and tick the go ragdoll box. So now when I'm hit, it should hopefully work. Or not. Okay, so not hit. What would be the best thing to do? Oh, wrong thing. Components hit. Let's go down here. Simulation generates hit events. Yeah, let's try that. Nope. Hello, hello. Okay. So why ain't this working? So I hit the capsule component. Let's tick it on here as well. Make sure they're both ticked as hit. I don't know if I can't know if they both have to be hit or not. Oh yeah, both have to be hit. There you go. Okay. So that worked. So when the hammer hits you, you're gonna go ragdoll. And let's do it again properly. So, boop. Oh no, didn't work that time. I think I have to walk into it. Yeah, so let's try walking into it. Yeah, it's when I walk into it, I think. Right. So, this is not what I want. Well, what I can do is if I go into my viewport here, right, and click on that hammer mesh and add the collision box on it. Yeah, box collision. And I'm just going to change the extents here. Well, not that. I want a capsule, really, don't I? Let's change that to capsule. Let's try it with a capsule. So rather than component hit, we'll do component begin overlap. Oh, that worked. Let's do it with that. Oh crap! Hang on. I'm getting too close to it. Hang on. Move you back. Okay. So there I go. I went. So unknown. I don't know what you thought I looked like, but you sound exactly like how you look. Okay. Thank you. Okay, so we got the hammers kind of working. So the reason why the body goes away from the camera. So the way physics work is your capsule component is what's attached to it, but when you assign physics to your mesh, your mesh is flying off separately from the capsule component. So to make it go with the capsule component, how can we do that? We can also simulate the physics of the capsule component, I guess. So on the Go ragdoll, I'm going to take my branch here, take the capsule component, and also set that to simulate physics. So can copy that out, and hopefully that will work. Yeah, kind of. Yeah. Koenig, how long have you been teacher for what grade? So I teach at college level and university level. So that's 16-year-olds and up. I don't know what that is in high school grades, unfortunately. But I've been teaching for 9 years now, I think. Always teaching games. Unknown, are you going to carry on the FPS series? So the FPS series is an FPS RPG series. So most of that stuff is going to be in there. So check that out. That's on there. Farian, honestly, I always thought you sounded like James Acaster. That's not the first time I've heard that. I don't think I sound like him at all. It was complete different sides of the country. So seeing your face the first time was also a surprise. People were when I was growing up, used to think I looked like Harry Potter / James McAvoy, which I don't really see the James McAvoy too much, but I do get the Harry Potter one quite a lot. So we can also scale down hammers, and they still work the same. The capsule component is going to keep rolling because the capsule component is it's cylindrical, so it's just going to roll. So I wonder if we can use a physics component on here to keep the two together. Constraint, physics constraint. So I'm going to use this to try and keep them together. So component name 1 we'll call the capsule component, and part 2 is going to be the mesh. Constrained, yep. We should be able to leave everything as is because we don't want to change too much. Twist, yeah, we'll leave it a twist. Okay, let's see if this works. No. And we can see, if I turn on the capsule's visibility, we can actually see this. Hidden game. So one of the benefits of doing a live stream version of tutorials is that you guys get to see me actually figure stuff out. Because some of this stuff I ain't done before, so I'm just figuring it out as I go along. So you can see the capsule rolling around separately to the body. So why is that not constraining it? I should have constrained it. If I spot it right. Yeah, should be fine. Disable collision, enable protection. Locked motion. Yeah. We'll say locked. I'm gonna lock it down. Let's see what happens now. Maybe if I turn off the physics of the capsule now. Let's try doing that. Oh, no. Off you went. I think it's not a big issue. We can keep it going on, but ideally you want it to join the two together. Open man mesh. Yeah, I don't see why it wouldn't lock it down. You're welcome, Angus. Unknown, it's so weird why you don't have 1 million of subs. Your vids are great and easy to follow, and you do vids for pretty much anything. I know, right? Why haven't I got 1 million subs? Crazy, right? Yeah, that's why I started following. I wanted to make sure I show people how things work rather than people just copy and pasting. Which is why I started the channel, because my students would just copy paste stuff off some YouTube channels. I'm not going to mention the names. And it was always wrong. I was like, why are you doing it like this? And they're like, oh, I watched the video and it told me to do it like this. I'm like, no, don't do it like that. I don't know why. I don't know. We have to come back to that. The main thing is that we got hit by hammers. Oof. I tell you what if I attach the camera to the mesh? So now can't now see something. It's a little bit out. I can't remember if this matters, if it's attached to anything. Let's attach it to the mesh and see if that changes anything. No, the capsule's still not with it. I don't know what to do with that. Yeah, Koenig. People want to use flashy stuff all the time. Yeah, I can see where you're pointing there. The problem with that is if you teach people how to use, like you can get people to use the Paragon assets. That's not a problem, but it's not. You want your learning stuff to be lightweight, and in time you scale up to the bigger assets and learn how to use them. Right, I'm not going to move on. I'm not going to dwell on this bit for too long. Let's go on to another trap. So let's make another blueprint class. Let's try making a seesaw. Okay, so for this, we're going to have a plane. Actually, not plane. Let's use a cube. And let's just flatten this up. Again, ideally I'd model this, but I cannot be effed to do it right now. Okay, let's do that. Okay, seesaw. So this will have a physics constraint. Because what you want it to do, you want this thing to be a physics object, but you want it to be locked in place at the pivot point. So let's see if I can remember how to do this. So we need a physics constraint. So type in constraint. There. So component 1, name of the first component property to constrain. If actor 1 is null, we'll look within owner. If this is null, then we'll use the root component of actor 1. It refers to actor 1, but you don't actually enter actor 1 anywhere. Unless I'm missing something. No, I don't know. Okay, well, let's do this. So cube is the first component, and we'll leave actor 2 blank, and it should constrain it to the root here. Should. So without changing your settings, let's see how this looks. Back down to the world. And I've got to simulate physics on this thing first. Right, so we've got angular movement, like that. So you get the gist of it. Yeah, it locked it into that place. So we need to lock it from rotating, spinning, and so forth. So if you go to physics constraint, you'll see angular limits. And down here, you should be able to change their motion. So swing one motion. I can never remember which one is which. Let's just experiment. There's one that locks it in one direction compared to the other. So let's change that one there. Right, so that stops it from the Z-axis spinning, by the looks of it. So then I want to go to swing 2, lock that. Okay, that's good. Right, so we've got the seesaw going the wrong way there. So let's change that. So swing, twist, movement, free, limited. So I'm going to lock that and this one to be free. It will be limited eventually, but let's just get correct first. There we go. It's just seesaw. I don't know why they don't name these something different, because swing 1 and swing 2 and twist is bloody annoying. So there we go. So that is for swing 1 is locked, swing 2 is free, and twist is locked. And that gets us a seesaw. Yeah, pretty simple. So do I have any blend spacer tools? Yes, I do. Depends what kind of blend spacers you want, but I've got a few. If you look at my animation series, you'll find them on there. So if I scale this up and out. So the physics constraint is going to constrain it in the center there. And it's going to work like a seesaw. Okay. So if we were to say put this up higher, like so, and push play. Oh, I hit the bloody, let's move, get rid of the hammers. Okay, hammer time is over, time for the seesaw. Why ain't it moving? Is it stuck in? Have I moved it into the wall? I think yeah, I have. There we go. Play. Whoop. Yeah. Pretty good, eh? And so you can use that as a platforming puzzle, and you run up and jump. Nice. So there's a few things you can also tweak on this. So if you go to the constraint here, you can see where is it? You can change how stiff it is somewhere. So swing limits here. If you change that from free to limited, you can change these things here. So if I change the stiffness here to, say, 100, it will now be stiffer. Crazy, right? And likewise, if you went low, change it to 5. Okay, and you can tweak dampening, contact distance, restitution is bounciness. I don't know what you have to do to turn that on. Don't know. But you got swing 2 limit. So swing 2 limit there. If it's limited, you got an angle. So that's how far it can swing, 45 degrees. So if I change this to say something a bit higher, let's say that to 70. And let's put this a little bit higher. So I have to jump up on it. It will now angle a lot further. So how to make him slide down? So let's take a look at the player character for that. So you typically, if you go to the third person character, go to the character movement, and we should be able to see walkable floor angle 44 degrees or 45-ish degrees. So if I tweak that to be a lot lower, say 20, hopefully that'll make it impossible for him to walk up it if it's too steep. I can't get up this bit. I can't get up this. Right, let's just get up there. So it slides you off. So it's too much. Let's go back to here. Let's change that to 30. I can actually walk up these now, so that's alright. So let's go to here. It gets too much. I should be able to slide off. There you go. Okay. Yeah. There you go. This will be going up as a VOD in 2 weeks' time for everyone else, but patrons will get it straight away. Okay, so that's pretty much the seesaw done. There's not much else you can really customize with it. You just place it in your level. So if we were to have multiple of these, yeah. What would be ideal though is get them to reset back to their starting position, don't it? So let's see if we can find a setting that does that. So swing limits, contact distance. How to make it reset? Not too sure what setting does that. So let's look it up. For physics constraint. Reset. Not much help out there. Okay, just gonna have to figure this one out. Okay, so angular motor. Between the current rotation of the seat and target rotation, no, this will not work. Yeah, okay. Twist and swing. Path is composed in twist and swing. Doesn't follow shortest arc and makes sense. Gimbal lock does work with locked angle constraints. Then let's try it out. see what happens. Not useful. Nope. Swing 0. Oh, maybe that's what I have to do. Ah, so there you go. It's got a bit of spring on it. Okay, so this motor here, from what I understand of it, hang on. This is a motor, and if you set the twist and swing, it's going to try and reset the twist and the swing component to whatever you want. So I had to tick on the drive for the swing, and by default it's setting it to 0, 0. Now the strength here is a bit too high for my liking, so if let's change it to 25 and experiment with that. Because you want it to drive it back up. So basically it's like a spring-loaded mechanism. It goes round and you let go, and it's constantly fighting you. We don't want it to fight us too much though. So it's still a bit too strong. So it's dipping down, but it's still too strong and fighting us a lot. So let's change that down to 10 then. Hit play. Obviously the more people that were on it, the more it would fall down. So still a bit too much. Let's change it down to 1 then. Okay, so there we go, that's it. And it should now drive back up. Maybe knock it up to 2. But this is the kind of thing you want to do. Just experiment and test things out, tweak numbers. There's no real hard and fast rule. You just got to just play with it until you get a good feeling for it. And this feels quite nice. It falls me off. And then it should reset. Yeah. Yes, it's trying to. There you go, a bit of fun though. I see some of you got to angular motor before I did. Well done. Great job and idea on the tutorial. Excited to see how you get the physics working of the characters. So, what else should we do? You guys have played Fall Guys. Tell me what you want to see us try and add in here. So, what other traps were there? There was the doors that open and close and knock you down, and things like that. So let's try doing one of those. Door. So we're going to have a cube. And this will be one of the posts. Oh no, we'll just use this as a door. Let's just change the size of it though. There we go. Let's see how big that is. I don't think that's going to be too small. Yeah, too small. Let's try that. Yeah, that might be right. Okay. So go to event graph and on begin plate, we're going to do a timeline. Door movement. Add a float. Door position. So if you've seen my door tutorials, this is standard fare. Add 2 points in there. So here I'm going to have a point at the end here set to time of 1 and a value of 1. And this one here is going to set to time of 0 and value of 0. Length here can be 1 second, and it's going to in fact we'll We'll leave it like that. I'm not going to tick loop because I want to make it so it's customizable to the point where you can make it go to the top and pause for a bit and then it drops down. So you can really mess with the timing of it like you do in Fall Guys. So when it starts this, we're going to get the box, the cube for the door, set relative location. Now, I've seen some people get confused the difference between relative location and world location. So relative location is the location of this component relative to its root. So at the moment, its relative location is 0, 0, 100. And if I move this up and down, the relative location is changing. However, if I go into the world here, I can see the world location is minus 140, 150, and 130. I want it to move relative to the root. So the door is technically standing still, but the mesh for the door isn't. And that's what relative does. So we're going to go to update there. And we're going between 0 and 1 because we're going to do a normalized version of this, which is better as it's more flexible. So now it's going from 0 to 1, which is basically no movement to full movement. So if I go to the height here, so that starts at 100, and this has got to go down to minus 100. Okay, so if I take that information into the event graph here, and we're going to do door position times vector. Where am I looking? There we go. We want to do you want to minus in the Z, so minus 100, no, minus 200, because when it's 0 I want to do 0 times this, add, which gets us 0, but then add the offset. I think that's right. The math sounds right in my head. Okay, so that does that. Push play. Cool, goes way down the floor, which is what we want. So how to make it go back up? Well, here comes the funny business. So I've got my thing at the end here. I need to make a thing at start here, custom event, to restart the door. So door up. So door up, we're going to go reverse from end. And that'll do that. Next, we're going to do some variables. So this will be where we can customize it on the editor level. So customize its speed, customize its wait period at the top, and that's about it. I can't think of anything else. So we're going to say speed and change that to float, and then add another one, and this would be wait time at top. And we'll also do wait time at bottom. Bottom. Cool. Yes, this is live, by the way, everyone. Hello. What are my favourite games and games? I'm back into World of Warcraft. I love it. Can't wait. Can't wait for the expansion. So door up, begin play. Let's make another custom event here. Door down. Play from start, and we're going to call door down. Okay, so do that. Right, so this is where we tweak things. So we've got these two values. Let's change that. Speed, we're going to set speed to default 1. Wait time at top, default at 0, and wait time at bottom, default 0. They will need to be editable. And then we'll do set at the end here, set timer by event. And we'll do a timer. It's going to be wait time at top, this one. Now, the event here, I could drag it all the way over here, but I believe we can just do type in event and go create event and choose door down. That saves you dragging a pin all the way across over here. we're just going to call it. So door down, do that. So this is if it is going down, but this same timeline can be used if it's going up as well. This is where direction comes into it. So on direction here, we're going to drag this out, and we're going to equals or switch. We'll do switch, and you get the switch event for that. And going forwards, we'll go this one, and we'll copy and paste that all down for backwards. Now instead of wait time at top, we'll use wait time at bottom, and we'll use door up for our event. Hit compile, and that should do it. So sorry, that'll do the waiting times, but we've still got speed to it, a dish out here. So in the begin play here, before we call door down, you'll see your timeline is actually a variable now. Drag this out, choose get, and then from there we can change the play rate of this. So you can set play rate, and what we're going to do is going to take the current play rate, get play rate, and multiply it by our speed here. Multiplied by speed, and plug that in. So now our speed is now variable. So if I could drag this door out here, we've got one here. Let's drag another one out there. And this one, we're going to say speed is at 1.2. This one's got a wait time at top of 2, but no wait time at bottom. Okay, so hit play. So you saw the speed rate was really different there. Okay, so we've got one issue there, where wait time at top there is busted, and this one isn't going back up. So let's fix these issues. I think the issue is with the wait time. If it is set to 0, I think it doesn't go. Yeah, if it's less than or equal to 0 seconds, which is not what we want. So wait time at top and bottom, we can set default value of something really small. So 0.1 and 0.1 here. So again, slider range 0.1 here. We've done this earlier. We're going to set 0.1 in the value range there as well. Wait time at bottom. That way the editor doesn't accidentally put it to 0 and cause issues. So when it's 0, it basically sets it and clears it, which is what we want. Right, that does that. Okay, so that one is just doing the wrong thing entirely. Okay, so if it's going forwards, it's going... Oh, I've done it the wrong way up here. So door up, and that's door down. There we go. Got a slight jitter there. I don't know why that's jittering. But you get the gist. You got it there. Yeah. Not too bad. So let's recap what we just did there. So I took my settings in the begin play here. And we changed the play rate of it. So all I did was got the current play rate, multiplied it by the speed, and that's at begin play. So when the game starts, it sets it all up. Then I call door down. Door down is a custom event going to the play from start on my timeline. Got door up doing the opposite, going up from the reverse end. Then we're changing the position. So as position goes from 0 to 1, it's going to move it down into the floor. And we're going to do a switch then and check which way we're going. Are we reversing or are we going forwards? If we're going forwards, we're going to call a door up at the end. And if we're going backwards, we're going to call door down at the end. And it's as simple as that. And because we made them editable on the editor side, we can change these to whatever we want. 0.2. We'll change that to 5. And we'll call this 1. This one's now a lot slower. Okay. How we doing? Let's have a look at see what we've got in chat for a second. Okay, so hello. Barlon, how would you do the way Tiptoe randomly picks which floor tiles are safe? Ooh, good one. It depends on how they're doing it. I don't know if they're doing it completely random or they are doing a set path. If they're doing a set path, then it's dead easy. But let's imagine it's completely random. How would you do that? I would imagine you could do it, but when it initiates the level, it picks a random tile or random 2 tiles and tells it to draw a line from its starting point to the end point. So it knows what tiles are to the left and to the right of it. And it's always going to try and aim to go forwards to the end goal with randomized points where then it's going to turn left or turn right. That's the only way I could think of doing it really easily. We could try and remake it. Shall we try and remake it? Show slippery floors, please. Yeah. So let's do some physics-based floor type stuff. So for that, we're going to make a material. Slippery floor. And let's make a quick material that does this. And we'll do, we'll make it pink like they do in the game. And specular, we'll make it shiny. Set to 1. And roughness set to 0. And now we've got a slippery floor sort of texture. No, do. Right, let's delete the outdoors here so we can start fresh. Okay, so our floor here, we're going to make a physics material. So let's make a physics material. If I can find it. Miscellaneous. Physics material. There we go. Okay. Oh no, I've got to make one in the edge of here. Sorry, I have to go into project settings first. Okay, let's make a physics material. No. Physics material. Should be in here. Or am I missing it? I swear it was in here. Material. Am I being dumb? What have I forgotten? I swear it was in here. Am I being dumb? What am I being dumb about? Boys games, I see your thing. How can you make an endless terrain generator? You need that's a lot of work. That's a large answer to a tough question. If you're talking about like Minecraft style, then it's basically lots of maths. Right, okay, so what am I missing? I swear it was in here. Physics. Surface type, there we go. God's sake. Right, here we go. Slippery. Okay, now make a new physics material. Go in here. And you can choose the surface type to slippery. So there we go. So here we can change certain things. So friction here, we can turn it way down. So we'll do 0.2. Restitution, we'll leave as is like so and close out. Then on the material here, we can add a physics material to it. Bosh. And save and apply. So now we've got a physics material associated to a material. And that means that if we add this thing to a surface, let's do some comparison ones. Hang on. Put a cube out here. I'm just going to click save all first before I break this. By the way, my gold patrons, if you're watching, you guys will have these project files for you to take home with you as well. Probably tomorrow by the time I get around to uploading them. So you guys get to keep that. Okay. We'll do this. And like this. Okay, so this guy we're going to put on this one. And let's see if what it does. So we've got movement like so. No, not going to do it. Let's override it with this then. Probably need actual physics on my character's movement, don't I? We want to slow it down. Okay, if we want to slow it down, let's do that then. So on my event graph here, let's do a line trace. So I'm going to do a line trace directly down to the floor beneath it. So let's do a line trace by channel. Start point is get actor location. And we're going to go straight down. Add vector minus 500. Straight down. Out hit. Split that. You'll get physics material. I don't think we can do equals. No. What do we do? Get surface type. There we go. Get surface type. And if that is equal to slippery. Set walk speed. Oh, I need to character movement. Set max walk speed to, let's say, 200. It starts at 600. And if it's false, set to 600. Whoop. Oh, we actually got a caller function. No, wouldn't it? So we've got a line trace function here. It's going directly down, getting a surface type, checking if it's slippery or not, and then changing. It's not really slippery. It's like goop, isn't it? It slows you down. And if that's the case, on here we're doing tick, and we're going to call that line trace function. So now, as we move forwards, it slows down. Yeah, that's that. Okay, so hey, your question time video is still live? Huh? What do you mean? Sorry, Chris. What do you mean? Yes, question time. Are you asking is question time still live? Yes. If it's the pre-record from last week is live. It shouldn't be. It should be unlisted still. Don't know. It will be, so yes, the question time video will be live next week. So they're lagged a week. So patrons get a week as they happen. Everyone else get the week after. Just a way for me to say thank you to my patrons and give them something in return. Scroll back up and see what other people have said. Okay. I saw a video live, question time 2. Huh? Let's have a look. Let's try and see what the guy's talking about. Oh, we do about question. Yeah, it's not live. It's scheduled. That's scheduled for next Wednesday. It's not live. It's scheduled. You don't need to do line trace. You can drag out the node out of the character movement called get current floor. Very handy. Yes, you can. But the benefit of doing line trace is that we can then use it later on to detect what we are hitting when you do like fruit things, you know, all that stuff. But yes, I guess you could use the get current floor. And you get that. And then you get this. That's good. I never knew that one. That's cool. Yeah, that'd be better. I like that. I didn't know that one existed. Thank you, yes. Well done. Yeah, it's scheduled the 13th. It's not live yet. Wait, no, it shouldn't be scheduled the 13th. Hang on, let's fix that quickly. Oh, so it is, yeah. Hang on. Yeah, sorry, that shouldn't be there. That should be 15th. My bad. I'll put it back up. Okay. Thanks for that, Chris. Yep, I fixed that now. Okay. Right, so Binus, you wants to try and do physics-based movement. We could try that. Right, we're in the event graph. That's fine. Okay, so I'm just going to disconnect and move forward and move right. Move forward. Okay, so physics-based movement. The capsule here. Whoa. We need to simulate physics, but lock its rotation in the X and Y. And then, okay, so move forward. Then we're going to apply physics to the capsule. Did I tick simulate physics? Yeah. So we are going to. I don't know what would be best. Let's just try things out. So we need to add a force. It won't be an impulse. It'll be a force. I think. Let's have a look. What else we got? I think, yeah, just add force to it. So let's add force to the, not mesh, the capsule. Everything's attached to the capsule, so it should just move forward. And the force is going to be get forward component, get forward vector. Oh, look, not that one. Get forward, active forward vector. And we're going to multiply vector by, not vector, multiply vector and float. So the axis value will go into there, and the forward vector needs to be split. Because I only want the, no, I don't know. Oh, no, let's try it with just plugging it in. Let's see what happens. Add force. Don't need bone name. Yep, that's fine. That's fine. Okay. I need to tell it how much force though, don't I? So I have to multiply this by a force. Okay, so we're gonna multiply this by, I don't know what's gonna be a good number. Let's start with 100. This all depends on the mass of the thing you're trying to force as well. No, nothing. Much higher than. What's that, 100,000? Can't tell. I'm not locking any movement, am I? Stop position, no. Mode. No dampening. I'm going to turn off gravity for a second just to see it should push it forward. Yeah, okay, so that works. It just need to be a lot higher value. Up I go. Oh, wait, what's this? Oh, that's the line trace thing. We'll disconnect that now for now. Douche. Okay, so this just needs to be a lot higher number. Let's change that to acceleration change. Have an effect. Whoa, 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 whoa. Okay, guys, wait. Let's knock that down a bit. 100. Not enough now. 1000. So, obviously I'm hitting stairs, which is causing issues. Okay. So, not too bad. Can we do a maximum acceleration on that? Let's see what chat's going on about whilst we're looking at. Oh yeah, minus. There you go. You got it. Yeah. That's the problem. I'd have to look this way to see chat. People will give me the answers before I actually get to them. So to hear that familiar. What game mechanic am I working on? Physics-based movement now. So we got forwards and backwards, kind of. We need to make animation work with that. But yes. Why does Unreal need such high numbers to make an effect? It's based on real-world physics, and things require a lot of energy and a lot of force to move things, especially the heavier they are. Okay. So that's going to change acceleration, but I want to maximize my acceleration so it's not going to go too far. I should be able to set that somewhere. Maybe this. Walkable slope override. Maybe that'll work with the stairs here. Or I will have to change it from stairs to a slope. Let's actually see what it looks like with slope work going on. Oh, I can't because I can't turn. Okay, let's try to turn. I can't remember how the keyboard works for Fall Guys. Okay, right. Let's just crack on. So move right. We're gonna do almost the exact same thing. And I'm actually going to use the get out to right vector. And other than that, I think it'd be mostly the same. Okay, let's see how that looks. Okay, left and right works. I don't know what forward is now. My character is just spinning around. Okay. Right. So, right. It's hard to know where to fix that. Okay. Hit play. So if I hit right. Okay. So that's the physical surface, physical material doing its job there. Just by messing me up. So that's me hitting right. That, by the way. That's left. So I'm still spinning. So I shouldn't be spinning. Why am I spinning? Lock rotation. Let's lock rotation to Z. That's better. So if I let go, I want this thing to just carry on if I meant to be slippery. Okay, so I can't go up the stairs. The stairs are weird because they're not sloped. They are actual steps. So let's up the angle on these things. Okay, so let's tick that box at the bottom that we saw, which was walkable slope override. So walkable slope behavior unchanged, increase walkable slope. Okay. Okay. Let's try decrease walkable slope. So this should hopefully make it so it goes slower up the slope. Or not at all. Maybe it's too slow. Let's change that to then increase. Oh wait, walkable slope angle. Let's do 40, because that's what it was set on the character movement component. Oh. Physics is always a weird one where you just have to keep testing weird numbers out to get what you want. Well, let's have a look at chat, see what's going on. Good night, Karen. Thanks for joining us. We could use a control rotation forward. That you could do, yeah. That's not the main problem at the moment. At the moment, I kind of want the camera to be separate from the rest of it. Change it to unchanged to see if that makes any difference whatsoever. No. You need a good run up. Not what we want either. Okay. Right, I'm going to change the animation. Let's get the animation looking decent then. So all that's happening there is I want the rotation of the mesh to match the rotation of the velocity. So I can just put this on a tick event, for example. And let's just get mesh, set rotation. We'll do set world rotation, I think. And then we'll get the velocity of the thing. Get velocity. And we want to make rot from X. Plug that in there. I think that'll do it. No. Make what from Z then? I don't think that's gonna be right. It's gonna be from Y, isn't it? Yeah, because my dude's upside down. Make what from Y? No, that's even worse than before. Oh, I know why. It's relative rotation because we've already rotated it. Relative rotation. The reason why it was messing up is because this is already rotated. Is make what from X. I was right first time around. Need to add the offset onto it then. So combine rotators, and we can add in the default, which is 270. And the Z here. 270. Compile that. Okay. And there you go. So now we've got a physics-based movement and sort of animations that go with it. It's just going up and down things. It's going to be tricky. What's going on there? Why is it doing that? Right, it's because he's going up an angle, isn't he? Oh. Maybe it's because I want only the if I split. Oh shit! If I split this, I only want the z-axis. So if I split that and just put in the z there. No, we have to do it the other way around. Whoop, 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 whoop. And then from here, split that, and just change the Z. Your plane. There we go. So let's fix that. We've got some physics-based animation and movement going on there. It's just getting up these damn slopes. Also, I want to lerp the rotation, not just set it. So let's lerp it. So I'm going to go and make a new variable here called target rotation, and make that a rotator. Now the reason you want to lerp it is so you don't get the snapping movement, it blends it. So let's disconnect this. No. Get target rotation set. I'm going to split that, just put in the Z there. And that goes there, that goes there. And totally messed up, that's meant to not go there. We need an R-interp 2. And the target is split, and we put the Z in the target. Delta time to the tick. Interp speed we'll do set to 5. We can tweak that in a minute. And current is get the mesh rotation. Get rotation. Relative rotation. Get relative rotation. No. And that will, we can split, we combine that and plug that into there. So now no, don't want that. Goes there like that. We don't need a target rotation, I don't think. Not too bad. Maybe a bit faster. Yeah, not bad. Remaking Fall Guys. Yeah, kind of. Yeah, we've made some traps. Sophie just joined us. We've made some traps here. We've got doors that do stuff. We've got hammers that do stuff. And we've got seesaws that do stuff. So we've got some physics-based movement here. We've got no jump in it yet. We can add a jump to it, I guess. And so that's what we're doing now. Someone asked to, I can't remember who asked for it now, who to do physics-based movement. I don't think Fall Guys uses physics-based movement. I think they use canned movement, and it just switches a ragdoll off and on when it need to. That's what my impression is anyway. But yeah, so I'm just going to take all that out and comment that and take that as physics based. I'm just going to reconnect it back up to the traditional based. But if you want to do it as a jump as well, a jump is just a fire an impulse up. So you add impulse and you just add the value to that to make it go up. So let's hook that back up there. I'm just going to turn off my tick here. Okay. So we got some stuff going on here. Oh, why can't I move? Oh, because I've got physics enabled. Yep. Okay. So when I get hit by a hammer, oh, there you go. What else is there? Okay, what about the revolving doors? Let's try doing that. Revolver. Okay, so actually no. Should I do revolving doors or should I try and do the tiptoe panels? What do you think would be better? The watch. Or try and figure out. Revolving doors are going to be quite easy. It's just another physics constraint that stops it from spinning too much. I can do that if you want, or I could do the tiptoe. Or try and do tiptoe. Why you decide? I'll tiptoe, 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 panels. Yep, okay, we'll do tiptoe. So, tiptoe panel. So let's see if we can figure this one out. Cube. I'm just going to leave it as a basic cube. Make it a bit bigger, but that's about it. Okay. One tiptoe panel. Tiptoe, tiptoe, tiptoe. Okay. Okay. So variable. This would be is solid. By default, is solid is going to be false. So I'm then going to have a box collision. And we're just going to increase the extent of that to the platform. Like so, okay. Then in my add event component begin overlap, other actor cast to third person character. And we'll make them disappear, okay? So if that's true, we can make it destroy actor. Okay. Well, actually, what might be better, rather than do that, let's do construction script is solid. We'll get and cube. If is solid is true, right, so if that's true, the cube here is going to be set collision enabled to no collision. Then on the overlap of this box, cast to third person character. If that is true, we're going to turn the cube to be invisible. Set visible to false. Okay, so to demonstrate an invisible platform, let's just delete this other stuff first. And let's put a platform here. Ah, wait, I need to get rid of the... Well, why am I still walking on that? I shouldn't be, because I've set it to... Oh, it's true. It's not, it's false, isn't it? Nope. Right, now let's do it. Okay, so fall through it. Sweet. Okay. This is going to be uploaded, yep. But Patreon will get it immediately after, and then everyone else will get it in 2 weeks' time. Right, so that's a panel, okay? So how do we know we want a panel to be solid or not? Well, if I tick this, if I just make this editable for a second, and tick is solid, push play. Oh wait, it's doing this if it is new visibility. Just drag that to the solid. Don't really matter. That shouldn't let you fall through it though. Why? It's only doing if it's false. If it's does it have any? I bet this cube doesn't have any collision on it. No, it does. Simple. Yeah. So why? I mean, it's no problem. We go set collision. You know. Oh, it's because we haven't done. Yeah, I know why. Because it's in construction script. I think we remembered this from the last time. So if I just change that to collision enabled. It's true. So if it is true at the moment. No. What the hell? Block everything. I tick that on. Oh, no. Is solid. Box. A cube. It said no collision. What? Yeah, that's what I want. So why was it getting weird? Turn it off. I should be able to walk on it. Or walk off. Sorry, walk through it. Yeah. I'll turn it back on. Yeah. What? My head. Why does this not work? Why does that not work? It's like once it goes to no collision, it just stops changing its mind. Yeah, if I go on there, it's remained at no collision. Nothing to do with the player collision, no. What the hell's going on here? This makes no sense. I can set it manually here, which is fine, but obviously I don't want to do that for every single one because it needs to dynamically change its collision. Yeah. If I change it then to is solid to false. Play. Yeah. Then put it back onto true. What? If solid is true. If it is true, set the cube type of collision to collision enabled. There's not really much to go wrong. It's only that. Yeah, I could try it on the begin play, I guess. Let's try doing it there. Whatever. Right, now let's turn it off. That makes no sense, but sure, okay. Yeah, and then back on. Well done, Abby Doody. Looks like it's worked it. There you go. Well done, Ab. Okay, so there's the one panel. The rest is build a grid up, and it takes to randomly pick one. So we need another actor to randomly pick one. So let's get rid of this wall, and let's put some panels down. An array of panels, some would say. Okay. Let's make that a bit bigger here. Do that. 1, 2, 3, 4, 5. Right, spacing. 6. Let's do 6 of these, and then how would be a best way of doing this? Okay, so let's just drag these out. So 1, 2, 3, 4, 5, 6. Okay, and let's put another platform on the other side so we can actually jump somewhere. Okay, so the trick for this is you're going to take these 6. These are going to be starting ones here. Then we go to my level blueprint, and we are going to right click, and can we get reference to all of them right away? No. Bollocks. Okay, let's do it one at a time. I'm putting this in a level blueprint because I'm going to let the level blueprint handle the logic behind the setup of the level. But you could do the game mode, could do another actor. Doesn't really matter. The level will probably be the quickest way of doing this, I would imagine. Okay, make array. These are your starting points, so I need to add these together. Okay. Begin play. And we're going to take to randomly select one of these. Okay. So let's get a copy. get the last index. No, get the last index. Random in range, and that'd be the max. Okay, so that's going to pick one randomly from that array there. And then we're going to take this one here and tell it solid. Set is solid to true. Actually, no. The problem with that is, so when it starts up, it's going to choose one of these, but then I'm going to want those to also pick one, and that's not going to happen quick enough. So okay, what we're going to do is we're going to make an event dispatcher for this thing. No, just do a function, custom function. Custom event here. Turn on solid, and that's going to just trigger this. The true. Save. So rather than do that there, we're going to do turn on solid. Now the benefit of doing that is then on the tiptoe panel, when it does call this, we can then do its check and randomly do a next one. For that though, we need to do line traces. So let's make a new function. Line traces, and we're going to do a for loop, and we're going to do first index at 0, last index at 2, so 3 times. And on its loop body, we're going to do a line trace by channel, and its starting point is going to be itself, so get actor location, and that going there, and then its end location is going to be this plus a vector. Now the vector it's going to add is going to vary based on which index we're currently doing. So we're going to take the which way have I got these facing? So X is forwards. Okay, always remember X is forward. So that's quite handy for that, because then if we set that 0 is going to be facing this way, index 1 is going to do that way, and index 2 is going to do that way. That becomes in very handy. So I can do this multiplied by a rotator and do in a Z 90, and then I can plug that into there and it will convert it, and we now can rotate out 3 times. So once I've got that, I want to multiply this vector by a length, and this length would be how far I want the line trace to go. So I think, what, let's say 750, I don't know. And draw bead time we'll do for 1 frame. No, we'll do persistent, so it sticks around. So it's going to do line traces 3 times, and it'll do 1 there, 1 there, 1 there. And using this out hit, then we can determine which one we want to. We're going to need to build an array out, don't we? Okay. So let's make a out hit split hit actor. We do cast to tiptoe panel, and if that's true, we're going to add this to an array here. So let's make a local variable, panel array hit, and that'll be tiptoe panel type, and that'll be an array. I'm going to drag that out, do add. So we're collecting what panels it has around it, And then when it's completed the loop, we are then going to choose a random one out of that. So if let's just do return node and put in our panel array into that. Save, save, save. Right, okay, so we're doing a line trace. We're going round 3 times around 90 degrees, so that way, that way, that way. And then we are checking if they are a tiptoe panel and storing it in a local array. Then at the end, when it's finished all those scans, it's then going to output that array. So it could have 3 or 2 or even 1 panel. Mostly 3 or 2s. On the event graph here, when it's turning solid, we want to do line traces. And then it's going to pick a random... no. So it's always going to go forwards, okay? And then until randomly it chooses to go left or right. Oh wait, also I thought of another problem. Let's do that other problem first. So the line traces, we need to check if they're solid before we add to this array. Otherwise it goes back on another one. We don't want that to happen. So we'll get is solid. And put into a branch. If it's solid, don't add it. Okay. Right. So now we only got ones that we could possible locations we can go. Now, we typically always want to go to the one that is facing more to the left direction to it, because by default, if we go back to here, so it's always going to go to the left. That's left up there. Okay, forwards is that way, left is this way. So it's always going to try and go left until it turns. Okay, I think so. How do we check that? Well, let's just get, if I just type in 1 here, just see this working. And then we'll go solid, turn on solid. So it's going to do a chain effect. So once it turns on 1, then it will turn on the next one and keep going and keep going and keep going until it can no longer do it. Okay. In fact, we'll do a check here. Go length. Oh, is it empty one of these? Empty? No. So length, if length is less than or equal to 0, false will go into there. Right, so how do we actually check this out? When we turn on solid, we want to do something else as well, don't we? So let's say we get the cube and we set material to something else. So we can test it and see what we're looking at. Let's change it to gold. Okay. Compile, save, done. So I push play. So there's the first one, gone gold. And it's done the hit trace. So you can see the line traces going out. And one's going the wrong way. There we go. So let's turn that around. Line traces. So rather than 90, do minus 90. Right, so I picked a random one again. The line traces worked this time around. Yep. Okay, but it's not picked the next one. Okay, so let's do that. So done that, done that, done that. So it's getting that far. It's getting this far. Doing line traces, which we've seen. We're getting the length. If it's less than or equal, let's change that so it makes a bit more sense. If it's greater than 0, get the first one and turn on solid. No. Oh. The collision, yeah, that's the next problem. We'll worry about that once we've got them. Just want to see a gold line going straight from one end to the other. That's the first thing we need to solve. Why is that not working? Are we at least getting this far? Let's pinch string this. No, not even getting that far. Turn on solid does that. And this goes on. Turn on solid is solid. Cube, yep. Line traces, yep. Okay, let's pinch string the length of this thing. Zero, that ain't right. If is solid is false. Oh, hold on a tick. Oh shit, they're all solid already. Fuck. Okay, hang on. By default, it's set to solid. Just hang on, that'll be why. So then we need to start off as not solid. Right, turn it off. Right, so that should, yeah. Okay. No, why are you not working? Ooh. Okay, let's just do the begin play thing that you've brought up. Do that and there. It's just getting messy, but hey ho, it is what it is. Okay, and set goes into the branch. Does that, does that, does that. Okay. Right, it's not even detecting that hit now. And that's because they're not solid. So the problem was the cube. We need to tell it to, rather than no collision, just do it to query only. And up here as well. So line trace still hits it. Aha, there we go. So now we've got a solid line and we should be able to walk along this. Yeah. Cool. So yeah, bush, 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 bush. But if I were to go off that path, it should fall through. There you get. Why? Collision of query only. False. Query only. Enabled. Why? Why can I still walk on that? It shouldn't do it because it's got no, it's query only. It's getting late. I don't want to carry on for too long. I'll get rid of this thing. Yeah, we could make it delete the mesh, I guess. Rather than change the visibility, just delete the mesh. But you don't really want to do that because you want it to turn back on, don't you? After a time, so when you reset, you just keep having a crack at it. If I change... I don't get it. Change to no collision. And it'll fall through. Which is correct. The query should be just the same. Doesn't trigger. Should do. It's solid is false. At start they're all false. So this one here is false. So that should trigger false there, down here. Done. I'll print string it for that certain. There you go. So that bit's fine. I don't know, any suggestions why that's not doing its thing? No, you don't want to simulate the physics on a capsule component. Oh, I see what you mean, yeah. No, you wouldn't want to do that. This should work. I don't know why it's not working. The query for it is stupid. Custom. Query only. I don't know. Okay, rather than do the collision enable then, another workaround we can do. Set collision response to a channel. Do the same thing here. Target is cube. So the channel is going to be a pawn, which is what the character is. New response is going to be, if it's true, to block. Otherwise, ignore. Pawn. We'll do it this way. Okay. Right, that works. Oh, that bit didn't. Fix one thing, break a million others. Right, so the line trace isn't hitting these. Oh, I think it's because I, by default, set it to query only. If I change that to... Oh, no, it should still trigger the bloody... Oh, I know why we're working. Oh, fuck. Never mind. We'll just leave it collision enabled. Okay. So... Oh, no, it should still... Kind of walk on this one? No. On block, on ignore. So confused. I think the construction script might be breaking it. Let's delete the construction script. Right, by default they're all set to no collision, which is not helpful. Oh, I can't. Oh, you fucker. Do I have to go to each one, really? Okay, we're going to make something. Right, we'll make it editor utility. And we'll do asset action utility. So here's something new for you. So set cube to collision, whatever you want to call it, I don't care. So go into here, and you make a I think it's run. I think it's run. So you get selected actor assets. There you go. Do it for each. So this is quite a cool little thing. And then what you do is you can make functions that work in the editor to speed up workflow, like what we need to do now. So cast to tiptoe panel for each one, and then we're going to get the mesh for each one. Or cube, sorry. Get cube, and then we're going to set collision enabled to collision enabled. Compile and save, and I think that's it. Might miss a bit. So if I select a few here to test this out, then right click on them, and you should see somewhere. I may be missing something. Do I have to add this to the world? I don't think I have to. No. No. It's like asset action, maybe? There's like a thing you do here. Have I got the wrong function? Yeah, that's... what am I missing? You right click on it and you'll be able to choose something from here to use that code we just did. Keep in mind as well, Farland, that they did make the mini games and a whole game over a number of years. I'm doing it for an hour and a half. No, 2 hours. I don't know how long. 2 hours we've been doing. No, I need to Google this. It's going to bug me otherwise. Hang on. Blueprint. No, what's it called? UE4 editor. Utility blueprint. What have I missed? It's not that one. It's a custom event. Oh, have it crashed? If it crashed, we're ending this. I don't know how long ago it saved. 425, you son of a... I've got to open it up to make sure to see how far behind we were. Ugh. Let's see how bad the last save was. I'm not loading up anything now. Oh, that's in it. You're welcome, Mustafi. Hi, Ryan. You're just joining us. Unreal just crashed on me. I think we lost all our work. We'll see how bad it is. If it's bad, then... How far ago was the autosave? Oh, come on. Oh, I've seen it do this before. It's well bugged, isn't it? Okay, I think we'll have to end it there. God's sake. Oh well, we'll end it there. It's been a long show anyway tonight, so thank you so much for everyone for joining me. What have we covered tonight? We've covered physics-based movement, physics constraint. So we created a hammer that span We created a seesaw. We created movable doors that go up and down. We started working on the tiptoe tiles. Made some progress, but then we have to crash. Unless I can get it back. We'll see. I'm going to try and get it back. If I do get it back, I'll put it up on for my gold patrons, and you guys can have the project files. The video on demand of this live stream will be going up publicly in 2 weeks' time. Patrons can see it tomorrow. So thanks very much for watching tonight, guys. Don't forget, Patreon has got loads more videos than YouTube does. It's got a load of the whole crafting series, FPS RPG series, skill system, level detail, IK, online multiplayer. Plus a load of bonus one-off videos, loads of stuff on there. So go ahead and check out Patreon. It's just $1. You join it and get access to all that stuff. So thank you, everyone. I think we're going to call it night. I'm getting quite tired. So thank you so much for joining me. Don't forget, on Wednesday we have question time. So if you have any questions about games development, UE4, anything you like, I'm here to answer your questions. So come by on Wednesday at 11 PM BST. Every Wednesday, that is. Thank you so much for joining me tonight. It's been a long one. So what are you coming out this week? So this week, we're going to see. You're going to see more crafting, probably more online, and maybe more IK stuff coming out this week. We'll see how we're going. But all those things are on Patreon as well. Patrons can continue seeing the FPS RPG series, more online stuff, plus some of bonus stuff in Niagara, because we've done one video in Niagara. We're going to do a few more. And I've got a special announcement coming up in next week about what to expect for our 3rd year anniversary stream. So check that out next week. I'm announcing that. It's got some cool stuff planned. I can't wait to share it with you guys. So we'll see that next week. Thank you all for everyone. Say come by next Wednesday for your question time, and you can ask all the questions you have. I know you've got a few questions that you want to answer, but it's just going on quite late, and I hear my wife grinding her teeth upstairs, waiting for me to come to bed. So anyway, good night everyone, and stay safe. Bye.